Hello everyone, welcome to my channel. Myself Vignesh Anand. In this video, we are going to see about the DC motors, their working principle, constructions, and their types. So, coming up to the topic DC motors. This is one of the types of your electrical motor which converts electrical energy into a mechanical energy. It is work principle of Fleming left-hand rule and electromagnetic induction. So normally a DC motor works is based on the uh, when a current carrying conductor is placed in a magnetic field, the conductor experiences a mechanical force. This was the basic outline of your working principle. So there is no constructional difference between your DC motor and DC generators. The same DC machines can run as a motor or a generator. So, as you know, the Fleming left hand rule in the sense, just stretch your three fingers of your left hand, which is your thumb finger, forefinger, and your middle finger. The thumb finger references your force, forefinger references your magnetic field, and your middle finger references your uh, current of the direction of the current. So, this is how the Fleming left hand rule illustrates. All the three are 90-degree and perpendicular to each other, and here the DC motor works in a Fleming left hand rule only. Then coming up to the constructions, the main parts of your DC motor is same as like a AC motor. It consists of a yoke or a frame, then a field winding, armature winding, stator rotor windings in the sense. Then stator core and your rotor core, which means your field core and your armature cores. Then additionally, it has a commutator segments which uh, produces your unidirectional torque, and then your brushes which is connected with your load in order to run the machine. So in here, yak or frame is your outer area, which means your outer covering of your machine, and it is made up of a cast iron or a steel, and also it is insulated in order to uh, environmental free. Next, poles and pole shoes. Pole are joined to the yak with the help of bolt or welding. They carry a field wiring, and pole shoes are fastened to them. The pole shoes they supports the field coil and spread out the flux in the air gap uniformly. Next is your field winding. They are usually made up of a copper. Field coils are former wound and placed on each poles and are connected in a series conditions. So they are wound in such a way that when energized, they will form an alternate north and south poles in order to form a field, which means in order to produce a magnetic field. Next is your armature core. It includes a high number of slots within their edge. The armature conductor is located in a slots. The material is used as a cast iron. They provide a low reluctance path, which means low. The opposition of your magnetic field is your reluctance, so it produces a low reluctance path for your flux uh, with the field winding. The laminations used here in order to reduce the loss, which means your eddy current and hysteresis loss can be reduced for using the laminations. Next is your armature winding. It can be formed by interconnecting the armature conductor. So whenever an armature conductor is turned with the help of prime mover, then the voltage as well as a magnetic field get induced within it. The material used for the welding winding are conducting material like copper. Then commutator, it is mainly used to collect the current from your conductor, which means your armature conductor, as well as supplies us current to your load by using the brushes. A commutator periodically changes the direction of your current between the rotor and the external circuit. Hence, it acts as a switch using which causing a unique directional torque in the DC motor. So the commutators can be built with a huge number of segments with a hard copper bronze. Then the brushes it collects the current from your commutator and supply it to your external load. The brushes are made up of a graphite or a carbon. The armature conductor in which the armature windings are been placed, and then the commutator and the brushes are connected with the armature core or armature windings. So in order to uh, collect the sources and then supply it to your load, we are connecting like in a such a way that uh, then the field winding is placed in your poles, and then the interpoles are been also been given. The commutator and the carbon brushes are been clearly mentioned. So the armature conductor is connected with your commutator in order to takes the armature current, and then further gives it to your brushes, and the brushes are connected with your load, in which the load gets a supply. Next, coming up to the working of your DC motor. So when the terminals of your DC motor are connected to the external source of DC supply, the field magnet are excited, developing alternate north and south pole in your field winding. Then the armature conductor carries a current due to the electromagnetic induction. Then all the conductor under a north pole carries a current in a one direction, while all the conductor in a south pole carries the current in a other direction. So according to the Fleming's left hand rule, it is clear that the force on each conductor is tends to rotate the armature in a anti-clockwise direction. So due to this, the conductor moves from one side of your brush to other, then the current in the conductor get reversed. At the same time, it comes under the influence of your next pole, which is opposite polarity to that direction. So consequently, the direction of the force of your conductor remains same. In here, the commutator in the motor works as like in a generator by reversing a current in each conductor as it passes from one pole to another pole. It helps in developing a unidirectional torque. Next, coming up to the main thing, back EMF. Actually, in case of generator, this opposition is provided by a magnetic drag, but in a DC motor, there is a back EMF get produced. How the back EMF is produced in the sense, when the armature of your motor is rotating, the conductor are cutting the magnetic fluxes lines, and hence according to the Faraday's law of electromagnetic induction, an EMF get induced in your armature conductor, and this EMF induced EMF which opposes your armature conductor, so that EMF is known as your back EMF. Next key point of your back EMF, actually the magnitude of your back EMF is directly proportional to the speed of the motor, and the torque is directly proportional to your armature current. So for example, if a DC motor is running in a load, which means normally starting load will be higher in your uh, normal operations. So sudden load, if any sudden load is been increased, means in that time the load will cause a decrease in speed. So if automatically the speed get decreased, means your EMF back EMF will also been get reduced, which means decreased, and then uh, it will allows a more armature current in that time due to this decreasing speed. So if the armature current is increased, it means automatically your torque will get satisfied, and torque will get increased. Hence the presence of your back EMF will makes the DC motor as a self-regulating and self-satisfying motor. So by this way the speed can be also been controlled or regulated by the DC motors. So this is your working of your DC motor in a conceptual way. So in here the armature conductor is placed in magnetic poles, which means your electromagnetic material, and then further the armature conductor is connected with your commutator and brushes, and that brushes will further connected with your external load, and this is how the operations takes place in your DC motor. Next type of DC motor, there are three main divisions. One is your brushed DC motor, second one is your brushless, and third one is your coreless or ironless DC motor. This brushed DC motor is further divided into a separately excited DC motor, self-excited DC motor, then permanent magnet DC motors. So separately excited in the means the field winding is fed with the external sources. Self-excited in the sense the self-excited the name itself you can easily know that it is a self-excited or self operated. So this self-excited is further divided into a series wound, shunt wound, and compound wound. Series wound in the sense the field winding is connected in series with your armature windings. The shunt wound in the sense the field winding is connected in a parallel with your armatures. Then compound wound. Compound wound in the sense it is subdivided into a long shunt and short shunts. Then permanent magnet DC motors. These are all the subdivisions of your brushed DC motors. Next few examples are applications of your DC motor. DC series motor are used in your electric tractions, cranes, rapid transit systems, conveyors, diesel electric locomotives, elevators, hoist, and trolley cars. Then DC shunt motors are used in your various machines like lathe machines, drilling machines, mining machines, then printing machineries, paper machinery, fans, centrifugal pumps, and blowers. Then compound motors are used in your elevators, rolling mills, shearing machines, planes, air compressors, punchers, then reciprocating machines. These are all the examples applications where we are using in your day-to-day lives. Hope you understand. I think so. These are all the basics of your DC motor. In next video, we will have a brief of your types of DC motors. See you next video. Have a nice day. Nandri Vanakkam.